There's a quiet that comes down when the darkness suddenly comes.
It was like you could feel the shadow coming over you.
The air was so clear that we could just see these streaks moving huge distances across the sky.
You feel it in a way that feels so different. The images don't do it justice.
And then you're just sort of locked in.
When you experience an eclipse, you feel that connection with space.
Oh my gosh!
Oh, look at the ray structure!
The universe is out there and it's affecting us. We are in space.
And here it comes, there's the diamond ring. And that is the most spectacular sight.
If you haven't seen it, you haven't seen anything.
The solar corona. So we have NASA's WB-57 high-altitude research jet.
Covered in snow.
So I'm glad they have a nice place to sit.
Exactly. And Kennedy Space Center, the famous rocket garden that we have at the visitors complex there, that's also a cool place to watch a partial
eclipse, yep.
Yeah. And then lastly, the Mentor Civic Amphitheater, a nice big field again to take a look out into and enjoy today's event. I'm sure that'll fill up soon.
Yes, I'm sure. Still gathering there.
All right, very much a party atmosphere we've seen in some of those watch parties, and especially here, again, the music, the exhibits, all the things happening here. Kind of reminds me of a sporting event, you know? So because of that, I'm going to ask you, who's the GOAT today, right? Is it the moon, is it the sun, or is it the earth?
I mean, I'm a lunar scientist, so I may be a little biased, but you got to go with the moon on this one, right? It's the moon that is like coming in for the block today. It's all the action to the moon.
I love that sports reference, but I'm going to have to say Earth. Because, well, first of all, we love our home planet, right? But because we're here, the moon has something to project its shadow on, and that's why we have the celestial alignment permitting. Yes, I hope that Cleveland here and everyone else along the path of totality will be good and clear. Okay, so let's take a look at today's path of totality. It passes through parts of Mexico, 15 U.S. states, and southeastern Canada. There's an estimated 32 million people who live along the path, and not to mention the tens and thousands of people who travel to somewhere along it as well, like us. You know, you're from D.C. and I'm from Florida.
No, I feel very lucky to be able to get to travel to see this one.
Yeah, absolutely. And we're going to have live reports from our correspondents spread out across the path, all excited to share this event with you. Some recognizable locations in between: the Indianapolis Motor Speedway, home of the famous Indy 500, and then also Niagara Falls, where officials expect up to 1 million visitors. Look at our team there waving at you. Happy to see you guys, and we'll hear from you soon. Okay, so again, we will hear from those correspondents, but also on our broadcast, a live interview with astronauts on board the International Space Station. Sarah's already ready.
So excited.
She's ready, because that's going to be obviously a unique place to witness today's celestial event, so we'll talk to them about that. We're also going to explain some of the science NASA will conduct during the eclipse and why that's important to you. And if you have questions about today's cosmic alignment, use the hashtag eclipse to send those in wherever you're watching us. We already have some questions from some kids.
Excellent.
And a celebrity. I can't wait to surprise you with who that is. All right, in addition to NASA's eclipse event here, there are plenty more in communities across the country, so why don't we take a look at some of them now. All right, so this is the California Academy of Sciences. That's a beautiful place to witness.
Wow, looks like they have great weather today. They're only going to get a partial eclipse there, but you know, still, that is more than enough reason to get outside and enjoy some time with your friends and family.
Waco, Texas, people have their seats. They're ready to go. They're all comfortable. I see some coolers there.
Oh.
And this is the Adirondack Sky Center. They have a big field for people to view. You know, a couple of days ago, we saw the same field. It was covered in snow.
So I'm glad they have a nice place to sit.
Exactly. And Kennedy Space Center, the famous rocket garden that we have at the visitors complex there, that's also a cool place to watch a partial
eclipse, yep.
Yeah. And then lastly, the Mentor Civic Amphitheater, a nice big field again to take a look out into and enjoy today's event. I'm sure that'll fill up soon.
Yes, I'm sure. Still gathering there.
All right, very much a party atmosphere we've seen in some of those watch parties, and especially here, again, the music, the exhibits, all the things happening here. Kind of reminds me of a sporting event, you know? So because of that, I'm going to ask you, who's the GOAT today, right? Is it the moon, is it the sun, or is it the earth?
I mean, I'm a lunar scientist, so I may be a little biased, but you got to go with the moon on this one, right? It's the moon that is like coming in for the block today. It's all the action to the moon.
I love that sports reference, but I'm going to have to say Earth. Because, well, first of all, we love our home planet, right? But because we're here, the moon has something to project its shadow on, and that's why we have the celestial alignment and show we're about to see today. That's where I'm going. That's how I'm going, yeah? All right, and now we want to know which team you're on. You can cast your vote by going to @NASA Solar System on Facebook, X, or Instagram, and we'll reveal the winning team at the end of the broadcast. Earth. The moon shadow will only be over land for about 1 hour and 28 minutes today, moving at an average speed of about 1,900 miles an hour. Keeping track of it for us is NASA's James Traley.
Yeah, thanks so much, Megan. I'm going to have to go with option number 3 there, the sun, because it gives us the energy for us to thrive here on Earth. And speaking of energy, it is bustling here at the Kennedy Space Center Visitor Complex. I'm coming to you from our new Gateway exhibit, where we today only have a partial eclipse, but still super excited to be tracking all of today's events live with our Eclipse Explorer. This right here is a fantastic tool that was developed by our friends at NASA Goddard Science Visualization Studio. They put this tool together for us to track the eclipse down to the exact second. If you wanted to get an access to this yourself, get a feel for how this is going to look in your neck of the woods, you can go to go.nasa.gov/Eclipse Explorer, and you can track where your city is going to be, your zip code, by punching it into this little box here. It's going to snap right to your location and give you some key stats. You just saw Cleveland there, so I can bring them up here. Cleveland is expecting peak totality here to start at 3:13:45 to be precise, local time. They've got a time of totality of 3 minutes, 49 seconds, plenty of time to really sit back and bask in their moment in the fully eclipsed sun. I'm going to be tracking all of this all throughout the afternoon for you to make sure that you do not miss a second of this coverage. Even if you're outside of that path of totality like we are right here, more than 99% of the U.S. is going to be able to see at least a partial eclipse. Some places are already experiencing, you just saw that footage from Mazatlan a little while ago, they are already experiencing a partial eclipse. And as always, if you are in partial, be sure to wear proper eye protection to protect your vision so you can safely enjoy today's fantastic celestial event. Plenty of awesome stuff coming up. We're going to keep a keen eye on that weather. Cleveland's looking nice and beautiful, very clear skies. Megan, back to you.
Levels, increased activity, eruptions that will affect the Earth.
So how does that affect the Earth, and how do we study those effects? What do we have, the tools, the assets to study those effects?
Sure. So we call the whole general thing space weather. So we get increased radiation, or what we call coronal mass ejections, chunks of the suns that blow off and hit the Earth. And those affect things like power grids and radio communications and GPS satellites, all of which are everyday real implications for that thing that's 93 million miles away.
And how do you feel? You know, you're a heliophysicist. This is kind of like your Super Bowl.
Pretty much, yeah. You are not the first person to say that to me today.
and are we right?
Pretty much, yes. I mean, this is it. I mean, 7 years, and I like to say there's the diving, trying to reach the goal line from the Super Bowl, 15, 20 years ago. That was like, totality, not totality, and yeah, today is it. I'm really looking forward to it.
Yeah, absolutely.
And we will have a whole bunch of fun here.
Yeah, again, eclipses are a unique opportunity to really study the sun and how it affects us. So I know that, again, your fellow heliophysicists and really across the disciplines of science, I know that today is really special for a lot of people.
It is, yes.
Thank you, Bob. I really appreciate you being here.
Thank you so much. All
right, it's time now to check in with our first team along the path of totality. Here is Tahira Allen in Kerrville, Texas, a city so lucky it gets a solar eclipse twice in a single year.
Thanks, Megan, and welcome to Kerrville, Texas. I'm Tahira Allen with NASA Communications.
What advice do you have? Where should they get started?
The easiest way to get started is to look up Night Sky Network. Night Sky Network has over 400 astronomy clubs in the United States. You would just use our search function to plug in your city and find the club that's closest to you. And if you don't have a club that's close to you, you can use our coordinator tips to start your own astronomy club.
Wow, that is awesome. And you know what? For folks, if you want some more details on the Night Sky Network and other things on how to become an amateur astronomer, you can visit go.nasa.gov/Night Sky Network. Now, a fun fact about today's broadcast that I absolutely loved learning was that so many of our telescope views that you're going to be seeing today are from amateur astronomers. And so, Kat, again, on this topic of, sky gazing, I heard that those in the path of totality might be able to witness more than just a total solar eclipse today. Could you give us a sneak peek on what we could expect?
Absolutely. So if we have clear skies in the path of totality, as it gets darker, you'll start to see two bright points of light. That would be Jupiter and Venus. And then as we get to totality, you'll be able to see the fainter planets, Saturn, Mercury, and Mars. And if you're lucky, you'll be able to catch Comet 12P.
Oh, what a crazy, cosmic alignment today, So, man.
Great. So for the amateur astronomers that actually want to view today's celestial event, what tips do you have for them?
So, of course, you need to have solar protection. You need to have solar-safe glasses. And you need to have solar filters for your telescopes, your binoculars, your cameras. But you can also use indirect viewing, like a pinhole projector box, or you can use a disco ball.
A disco ball?
Yes.
Wait, how does this work? Can you, walk us through this?
So as the sun hits the mirrors, and it'll cast a little reflection onto the surface here, you'll see little crescent shapes as the eclipse progresses.
That is incredible. As it begins.
Sure. Yes, the sun does affect life here on Earth. We have a term that we call space weather, which applies to the field of study of everything from the sun to the Earth and in between, and how that affects life here. We are fortunate that on Earth we are protected from things coming from the sun by our magnetic fields, which shield us from those explosions that come from the surface of the sun that we talked about. And those can result in really fun occurrences, such as the aurora. There can be some negative side effects, but those are mostly limited to things that are outside our magnetic fields. The storms from the sun can interfere with satellites, and it's something we really have to think about as scientists as we start to plan for putting humans on the surface of the moon or potentially sending them to Mars. Those energetic particles that result from the sun can impact humans, so that's just something that we have to learn about and take into account.
So the sun is always there, of course, but why are eclipses a good time to study these effects called space weather?
Yeah, eclipses are a really cool time for scientists to be able to study the sun. It's really hard to completely cover the disk of the sun in order to study the sun's atmosphere.
A treat for our viewers right now, joining us live in space, 250 miles above the Earth in the International Space Station. Everyone, please help us welcome NASA astronauts Jeanette Epps and Mike Barrett. Sarah, you've been waiting.
I'm so excited.
For this.
Oh, there they are.
Hello, everyone. Oh, Jeanette, Mike, thank you for joining us.
It's a pleasure to join you guys, and I hope everybody appreciates NASA scheduling this eclipse to bring the world together.
Yes, thank you so much to NASA, and thank you so much for joining us. Now you guys will have 3 opportunities to view the moon's shadow over North America, and that last pass will give you guys the best views. And we hope to also share those live views with everyone here on this broadcast around 3:30 p.m. Eastern Time. Now, Jeanette, I have 2 questions for you. Are you looking forward to being one of the few people seeing today's total solar eclipse from space? And 2, I know your crew member Matt Dominic will use a camera with a solar filter to photograph the sun being eclipsed by the moon. Will you also be taking photos of the celestial alignment?
I'm definitely taking pictures of the solar alignment. And I think we're very fortunate to be here at this special vantage point to see such a special event at this time. So I'm definitely excited.
What about you, Mike? What's going through your mind as you're preparing to see such an awe-inspiring event?
Well, admittedly, I'm a bit of an eclipse junkie. My first one was like when I was 19 with the homemade telescope in the desert, and a few since then, and actually during the 2017 eclipse, I was on a chartered aircraft several hundred miles off the coast of Oregon watching it, and I got a strange bucket list, and this is one of the things that's on it, to actually watch an eclipse shadow cross the Earth from space. So I'm ecstatic to see this box gets checked and just to see this amazing thing from up here.
Yeah, the fact that that was actually a box on your list is pretty amazing. And then now it's getting checked. So, you know, for those wondering, this is what the moon's shadow will look like to Jeanette and Mike. We're going to show you video taken from the space station of the total solar eclipse in 2017. And you can clearly see the shadow moving across the top of your screen there from left to right. We actually sped up the video so you can see more of that transit. This would look a lot slower to them, but really cool. Jeanette, eclipses give us a unique opportunity to study the sun and how it affects the Earth. Can you tell us about the atmospheric waves experiment attached to the outside of the space station right now?
Sure. We have an atmospheric wave experiment that's going on now, and what it looks at are these atmospheric gravity waves. And these waves transport energy and momentum up through the climate system. So with the imager on the atomic wave experiment, we're going to look at how these atmospheric gravity waves impact our Earth's climate, how it can impact our space and global and all of our comms, how it can affect our navigation system. And so over the next 2 years, researchers will use an infrared imager to look at the global distribution of these waves as well as their characteristics.
Mike, how does it feel to have a hand in maintaining the space station so that important science like the atmospheric waves experiment can happen?
Well, of course, the main reason we're up here is actually to conduct that science. We maintain the station to keep this platform what it should be, what it was built to be, which is a vibrant laboratory, which covers so many different disciplines on the inside and the outside, like the gravity waves experiment. I mean, it's an honor and a privilege, as much as anything, to have a hand in that science, and we end up being basically the eyes, the hands, the on-site presence to conduct that science. And we get to be the first to see results of just amazing things that are years in the making by a bunch of really smart, ambitious scientific teams on the ground. So that's really where the joy is. Maintaining the station is just like maintaining a research ship, something I actually quite like. So I feel very much at home in that role.
It's still blowing my mind. I mean, we're here in Cleveland, Ohio, live. You guys are up in space in the International Space Station. I can't believe the opportunity that has been afforded to us, and I hope our viewers really enjoyed this time with you. And I hope you enjoy the show from up there. All right.
We have, but we do want to close by saying, first of all, we really enjoy being here, but everybody stay safe. And use the simple means to protect your eyes as you look at the eclipse, as Jeanette and I are modeling here, which makes us blind as a bat on the inside, but solar protected on the outside. So we encourage everyone to do the same.
Really great advice from both of them. Thank you so much. Sarah and I have our glasses, and we're ready to go. Also blind if we don't do this. All right, again, Jeanette, Mike, thank you so much. Waco, Texas again. People look very, very comfortable in their camping chairs and spread out on picnic blankets.
They look like they're having a good time.
Yeah.
A few clouds.
A few clouds, but again, they have some time there before. Kennedy Space Center, they will see a partial eclipse. We have some people walking around the Rocket Garden.
Oh, it looks like they have beautiful weather there.
California Academy of Sciences, yes, they do. They have clear skies. We're very, very jealous over here. And then the Mentor Civic Amphitheater that's starting to
fill up.
Exactly. There were fewer people when we checked in ago, but now lots of people there and lots of people at the Adirondack Sky Center. I wish I could wave and say hello.
They look like they're getting ready for some stuff, though.
Yeah, absolutely. Again, the snow cleared out because there was snow over the weekend, but now it looks like a beautiful, probably still crisp day there for them. Okay.
Partial eclipse. You've been seeing some great feeds from our camera in Mazatlan, Mexico. They've been experiencing that kind of crescent sun for a little while now. They're just about 20 minutes out from actually experiencing totality itself. they're going to have a long window where they are 4 minutes and 17 seconds. For some context, back in 2017, the last eclipse that swept across America, the longest time was only around 2 minutes and 40 seconds. That was in Carbondale. This time around, some very long times, just a little bit northwest of Torreon, Mexico. They're going to get upwards of 4.5 minutes. A lot of time to really observe it, but just make sure that you know when to be outside. And as always, access that tool at go.nasa.gov/eclipse explorer. This is going to keep moving on. You see this little thing. I have this actually running in real time. This is our shadow of totality. This is going to continue to move further and further to the northeast and actually make landfall in just a few moments in Mazatlan, Mexico. As you've seen all throughout the broadcast, we've got correspondents all up and down the U.S., all the way up to Maine, covering this live. Very excited to continue tracking this. Make sure you know what's going on here. But for now, back to you, Megan.
People here to spectate today. Today we are waiting for a spectacle that is of a celestial kind. Of course, this is most known for the Indy 500, but we are waiting for something a little bit special today. With me, I have the 2016 Indianapolis Motor Speedway winner, Alexander Rossi. Good to see you.
Good to see you. Thank you so much for having me.
It's great to have you. So the Helio Big Year is a celebration of sun science and how the sun touches everything, including IMS. So tell me, the track when you're doing a qualifying round is about 4 minutes long, which coincidentally is the length of totality. So tell us, what is it like being on the track?
You know what? The sun plays a huge role in determining the performance of the car based on the track conditions. So we actually, when it's a day like this, as much as it's beautiful for the fans, it's actually very difficult for us as drivers, because as the surface heats up, the oils come to the top of the asphalt and it actually becomes slippier. So that's surprising to people. They think that temperature would mean grip, but it is until a certain point. And then once it kind of crosses over 100 degrees on the surface, you start to actually go the other way.
Wow. And tell me about those tires. How does the sun affect those?
So we use slick tires. So Firestone tires are slick. On a road car, you have tread, right? Because they're supposed to be used in all conditions. Slick tires actually have a bigger contact patch, more surface area, so they generate more grip at a temperature, right? So they operate between 180 to 230 degrees Fahrenheit. Again, the sun is good until a point. When they go over that 230 degree mark, you start to lose that grip again.
Ooh, all right. Well, we have a little competition going on today. We're trying to determine whose big day is it. Is it the sun's, the moon's, or the Earth? So my question to you is, are you Team Sun, Team Moon, or Team Earth?
That's a hard one, but I'm going to go Team Earth. You know, I just think we're still about to see. Go Earth.
Go Earth. You heard it here first. All right, guys, thanks. We'll be back here. Daryl in Niagara, over to you.
All right, thank you very much, Lauren. Just 500 miles northeast of you. We are here at Niagara Falls, right next to the Niagara River. This is a special location for a lot of people because it is a once-in-a-lifetime opportunity to see a natural wonder set against a celestial one, the solar eclipse. And so let's talk first of all about the natural wonder, and it all starts right here. Look at this massive river and the amount of water that's moving through here. 500,000 gallons of water, 500,000 bathtubs actually going over the falls at every 60 seconds. It's tremendous, the flow here. It interacts with the air, it hits the rocks, and it also, you know, it flows up a mist column that is omnipresent. This is always here. So one of the things that eclipse watchers want to see is, how does it interact with the light? Will we have a pink rainbow because only prominences from the sun will be seen and they're pink? We'll have to see about that. One thing we do need is a little bit better cloud clearing around here, because we do have some cloud cover. But that's okay. People who have gathered here are excited and they're hopeful that it will clear. Who's here? Well, I want to show you our camera from about 500 feet away. Look at all my friendly eclipse watchers. Are you guys ready for an eclipse? Yeah! Well, I love the energy. We could use this energy to blow the clouds out of here. As our camera backs out, you're looking at Terrapin Point, and this is the lawn here. It's roughly the size of a football field, and everybody who's here, a lot of people came in at 6 a.m. this morning. They currently cut off the park from anybody from coming further into Goat Island here. So this is the max capacity that we're at right now. It's that popular. Over to the other side, our friends from Canada. Look across the river gorge, about 1,000 feet away. Niagara Parkway is lined with people. So it's a beautiful shot over there, and we really appreciate our Canadian friends who have joined us. Now, this is our Canadian friends who have joined us. Now, this isn't just about the solar eclipse. We've been here for the past week, and we were at locations all across Niagara Falls, 12 to be exact. Take a look at this video. Crowds of people packed the Niagara State Park Welcome Center, where Commander Munikin Campos, the mannequin who flew around the moon during the Artemis 1 test flight in 2022, was on display. Our partners at the Canadian Space Agency sent kids virtually to space all week long. And NASA experts from the Kennedy Space Center gave presentations and talks at places like the Niagara Aerospace Museum and libraries across the area. The outreach was a huge success, with thousands of people participating in the events and passing through our exhibits. And we just want to thank everyone who came out to see us at all our locations, and we hope you left a little inspired about space exploration and a little wiser about all NASA's missions. Okay, coming up, we've got a very special guest for you who's going to share the eclipse with us, CSA astronaut Jeremy Hansen. He's going around the star today, the moon. Not the star, the sun, the moon, the star of the show, I should say. He's going to be here. He's interacting with the public. We're going to get his thoughts on totality along with everybody else.
Our vision for going back to the moon and establishing a sustainable presence is having a lunar gateway, a lunar space station that can fly successfully around the moon and sustain astronauts there. And we are leading the program that's developing the power and propulsion element.
NASA's Neil Armstrong Test Facility in Sandusky, Ohio. It's the only place in the world where you can test a full-size spacecraft for all the extreme conditions of launch and spaceflight.
Right now we have the Orion spacecraft. This is a spacecraft that actually went around the moon, but we're using it as a test article now to make sure that in the launch environment, that spacecraft is safe.
When it comes to aviation, every U.S. plane has NASA Glenn technology on board, which makes your flight cleaner, safer, and quieter.
And looking at solutions like electric and hybrid electric propulsion systems that will reduce or give us different ways of converting energy that are cleaner.
Our center partners with a lot of community organizations to share NASA's discoveries or just get kids excited about science, engineering, technology, and math.
I really enjoyed the VR experience. It was really cool to be able to sit like I was an actual pilot flying. I feel like I could potentially look into considering aerospace.
We just have a tiny little faint sliver left of the sun in Mazatlan, Mexico. We are expecting totality in 1 minute and 35 seconds. You know, joining us now to walk us through this, Kelly Korrick, an astrophysicist from NASA's Heliophysics Division. Kelly, tell us about the science NASA is about to conduct right now in Mazatlan.
So science that they're going to conduct is about the WB-57. So we're going to fly some planes over and make sure that we can actually see that solar corona, that that hot atmosphere that's around the sun that we're about to get once we reach totality.
Yeah, and it looks like it's almost there. Yes, it's almost there. You know, we have a view right now of inside the cockpit of one of the WB-57s, or at least we're efforting one, because as you said, this is going to be a huge part of what we do in Mazatlan.
Definitely, yeah. It's the
oh, there it is, Kelly.
There it is. Oh, look at that view.
So we're looking out.
That's great. We're looking out, and it looks like we might be able to. We're seeing a lot of clouds, but hopefully a shadow as well as we're coming in to totality there. And so, yeah, so these WB-57s are carrying 3 different instruments or 3 different experiments, 2 to look at the sun and 1 to look at our atmosphere, because our atmosphere actually responds to the eclipse. And we're trying to figure out how that ionosphere, that layer of the atmosphere, actually responds to it.
And you said it does look like there's already a shadow over land. You know, we also have a shot, and we'd like to pull that up now, a shot of the coast and the fact that it's already going on over. And you know what's really cool about all of this is we do have eyes all over this thing because we are collecting so much data.
Yeah, definitely. I mean, we have the stuff here. We also have rockets on the other side of the country being launched to, again, study that. Oh, look at that. That's the diamond ring.
That's right. We're not there, but I feel the energy just watching it.
Yeah, so this is because of the craters and the peaks and valleys of the moon, we're seeing the last bits that are just getting through, and now we're getting to totality. This is great. So you're starting to see those pink fingers out there kind of sticking out.
Wow. So again, totality here in Mazatlan, Mexico, the first community in North America to experience the moon completely eclipsing the sun. And if you are in Mazatlan right now, it is now safe to remove your eclipse glasses for the next 4 minutes. And you mentioned some of those pink filaments that we're seeing, right? Can you talk us a little bit through that, Kelly?
Yeah, so those pink filaments, because they're helium-rich, that's why they're appearing pink and they're hanging out there. Those could be the start of space weather. So there are lots of tons of material, billions of tons of material that could possibly be one of those explosions for space weather. The reasons why we really study the sun and try to understand how to live with the sun.
Well, can you explain why space weather is important to us here on Earth?
Definitely. So it's not just satellites that are interested in space weather. It's also our power grids because of those energetic particles coming from those big explosions that can happen in the sun. That could damage our power grids. It could also do things like interfere with GPS signals. And I know we all use our phones to navigate everywhere. So if we didn't have that, that would be a big problem. So we're looking to understand it better so we can all mitigate all those things.
Some of the movement we're seeing here is just our telescope operator adjusting because, again, they needed to make some changes for before totality. Now they're viewing it a different way, and then after totality we might see some shakes there as well. But I really just cannot believe how crisp it is. As we said, it's not a marble, but I mean just the view of it is so crisp with these little, again, those filaments are just amazing that we can see that to such accuracy, you know?
Right, definitely. And also the white fuzz. I mean, you're seeing something that's 1,000,000 degrees just hanging out all around the sun. And, you know, 3 billion Earths can fit inside of there. So there's a lot of atmosphere there, all around there, just hanging out, being very warm. And so, one of our mysteries is, and one of the B-57s are addressing.
There you go, WB-57, our pilot.
Yeah.
He's flying. So basically, Kelly, he is going to fly and try to chase down the shadow for as long as possible, keep up with it as long as possible.
Exactly. The shadow is much faster than the plane. However, they can chase it for a while and get an extra 2 minutes. So on the ground, we can only get 4.5 minutes, and they're going to get 6.5 for that plane.
I love that they're waving to us. Oh, there you go. And now we're flipped. Now we're seeing the front. So again, they are in night. I mean, it looks very dark with only some light in the horizon, yeah?
Right, yeah, and that's what we'll expect wherever we see totality is the night sky is very dark. You might even see some planets or stars, and then you'll see like twilight all around in 360 degrees.
What an amazing vantage point as well. My gosh. I'm very jealous. Kelly, are you jealous? I kind of feel like you're jealous.
I'm kind of a little jealous. Yeah, I kind of want to, see if I can make a faster plane so we can, follow it the whole way.
Plus, they're up above the clouds, so they don't have to worry
about the clouds. Exactly.
Well, I do want to say a big thank you to the WB-57 pilots and the whole team supporting them for that great view. That was awesome. Kelly, you have a wealth of knowledge when it comes to the sun. And for those watching, if you're interested in learning more with her, check out her and other experts featured in the Sun series of NASA's Curious Universe podcast. And that QR code will pop up on the screen, and that'll take you straight to the episodes. Again, look at that double box we got there. We're showing you amazing views during this broadcast. A big thank you, actually, to the Solar System Exploration Research Virtual Institute, or SERVI, for providing the telescope views from Mazatlan.
Yeah, the SERVI team down there, the SERVI team is based out of Ames, but it is a collection of teams across the country and across the world that are sort of studying the intersection of science and exploration, helping us get ready for our next trip with humans to the moon.
Yeah, that's amazing. Okay, totality is actually about to end in Mazatlan. Let's keep watching our screen right now for, again, what are we watching for, Kelly?
We're watching for the diamond ring effect. So that's when the first bright light, we're starting to see it on this side there. So you're going to put your glasses on right now to protect those beautiful eyes, because now we're going back to the partial phase.
Whoa, that's amazing.
Wow.
Yep.
Kelly, that's a filter, by the way, everyone. That's why we're seeing that. But when you said put on your glasses, I'm so trained now to do it that I almost did it here in Cleveland. No, we're fine in Cleveland. We're still in Mazatlan. Again, what we're seeing is because we needed to adjust the filter now that, again, it's basically like putting on our glasses. The way that you said people on the ground need to put on our glasses, our telescope operators need to protect their own eyes as well as their equipment.
Exactly.
Well, thank you so much, Kelly. I really appreciate your time here with us. It was so fun to learn about the science and actually see the first eclipse come for North America here. So thank you so much.
Thank you.
Exciting. So tell us, Reed, obviously everybody is excited, but have you seen a total solar eclipse before?
Never a total, so I will share this darkness with you and this whole crowd the first time.
Wow. This is incredible. So,
great.
too, you know, what considerations do you and your fellow Artemis astronauts need to think about when related to the sun when traveling back to the moon?
Well, it's great to see Pam Melroy on your last clip, a dear friend of mine, so it was nice to see Pam's face over there. But when we're heading out to the sun, it's really radiation is our big thing that as we're heading out to the moon.
Of the moon's surface, so we know exactly where the moon's shadow will fall. And you know where to be to see the eclipse in person, even if it's from the stands. Don't miss your chance to experience the beauty of science in action and maybe catch a ball game.
You actually can't see it. We are 2 minutes, under 2 minutes actually, away from totality here in Kerrville, Texas, which will mark the start of our eclipse coverage across America. Now, folks, we have a little bit of cloud coverage right now in Kerrville, so we are showing the Dallas feed. But again, we're holding out hope.
We are.
Gina and I are thrilled to be here with Dr. Nicola Fox, who is the Associate Administrator of NASA's Science Mission Directorate. Nikki, thank you for being here.
Oh, I wouldn't be anywhere else.
Thanks for being here, Nikki. So tell us how the science conducted today will really impact the future of exploration at NASA Science.
Oh, wow, there's so much that we're going to be doing today. We're going to be studying the sun. We're going to be studying the Earth's atmosphere and how that changes. You can see it getting dark here. And, you know, we've got these little magnetometers. They're going to be all across. We have 30 of them all the way across. I'm going to hold it up.
Very nice. Love magnetometers.
Magnetometers, and we're gonna be having these all the way across the path of totality. And it sounds like we should go.
We should get up.
Oh my goodness! Let's go.
Oh my goodness!
Less than a minute. Oh my goodness!
Wow.
Okay.
All right, glasses on, Nikki? Yes?
Yeah,
or
glasses
no?
on, but we're about to get. Yeah.
There's some cloud
there's
coverage.
some cloud coverage.
It's trying to peek out.
It is trying. It is trying. It is trying.
Windy,
it is getting
for
dark
sure.
here. The wind's picked up. You could actually see the birds started flying in a very weird pattern a minute ago.
Good point.
Come on, come on. Oh my goodness, we're there. We're nearly there. Okay.
Here we go.
Wow, the crowd is counting down.
Wow. Yes.
Oh my gosh, it's beautiful.
Yes!
Oh my goodness.
That is amazing!
Wow.
I told you! No! Go away, clouds! Go away, clouds!
They're gonna
Look
move.
at that! Oh my goodness! I have been saying all day, look how dark! Look how dark it is around here. Yeah?
It is just this white ring.
White ring.
Yeah, it's so dark.
It is so dark. It is
You
so
can see
dark
the planes in the sky
You
much
can.
better.
Wow.
You can.
Everybody's
We have
just
planes and
screaming.
helicopters and drones
The whole
all over
crowd
the place
is
today.
just
look
Here we
at
go.
the clouds are gonna clear
Look
for
at
us.
that. Yes! Yes! Woo! Woo!
Oh my
Look at that! Just
It's
look
amazing.
at that! That is
And we have
incredible.
about, what, 4 minutes
Oh, yeah.
to
4
just
minutes
bask
and 25 seconds.
To be
Yes.
I mean, this really,
Yes.
again, reminds you that we are on this one planet, you know,
Yes.
in this larger system.
And you have to be on this planet to see what we're seeing.
You do.
right now.
That's why we are Team Sun, Earth, and
Sun.
Moon. Because you need the moon for an eclipse. You need the sun for an eclipse. And we're
Right.
standing on the Earth to see it.
Oh man.
So, all of
Amazing.
NASA science represented by a total solar eclipse.
And something that, what, over 30 million of us today, at least in
at
the
least,
path of totality.
at least, yes.
Able to witness
yeah,
this.
31
about
people
you,
living in the path of totality. So
Doesn't
imagine
count
how
the
many people
travels.
actually traveled here. Yes.
Absolutely.
Yes.
This
Wow.
is getting me extra excited about all the science that
All the science that we're doing.
right?
Yes. Yes.
All right, those clouds are playing tricks
Those
on us
clouds
now.
are being pretty mean. Yes.
It was nice to get a taste, though.
It's
Wow.
true.
It is
Yes.
so dark.
It is.
We've got everybody
is
looking
so
up.
dark.
I'm so happy that, you know, for
So
folks that
good.
travel,
Yes.
able to see this take place.
That's right.
And
so-
it's been such a great atmosphere here all day. Every
Yes.
time the sun comes out, everybody
Everyone's
cheers.
cheering,
Yeah.
counting down. It has been incredible. And so, wow.
That's true.
Oh, Nikki, what's your favorite part about these? About an eclipse? Is this Is this your first?
No, this is my second one. 2017, I was in Nebraska and I saw it there. But I think there's just you can study the sun, you can study the corona, but suddenly you see it with your own eyes, and it's that feeling of just wow, that is our star. Like that isn't just the sun anymore. That's a star, and you see it looking like a star. And as we study. As we look for exoplanets in other galaxies that might be able to support life, we need to understand our relationship here on this planet with that star. And so it's so important. And I think when you see it, you're just like, wow, it actually is a star. Yeah, it's not just a bright point of light in the sky. You can see the structure. You can see just how exciting the sun is, and actually how dynamic it is.
Yeah. And it's not often in heliophysics that we can actually see the science that we're doing with our own eyes.
That is right.
So it's a rare experience.
Or even sharing it, millions of
have
us
so
today.
many people partake.
Yep.
Times Square, right? But they're stopping to take a look at this with us.
Beautiful.
Oh, awesome. So this is just next to us. This is Progressive Field here in Cleveland, Ohio. So the Guardians have their opening day today, and the first pitch is like after 5 o'clock. But as you can see, they've opened up the stadium, and people are in there to enjoy
big crowd
the
in there to watch that. That's great.
Yeah, you can. Oh my gosh, it just got darker here.
Yes.
Oh my gosh, that's so interesting. And then Mentor Civic Amphitheater again. The field starting to fill, and everybody looking up at the sky for their opportunity to see today's solar eclipse. This is us back here in Cleveland. Everybody looking up at the sky. We have 30 seconds until totality here in Cleveland, Ohio. Oh my God, I have goosebumps everywhere. Everybody's starting to cheer. I might cry. I kind of feel like crying. This is so cool to see. It's getting so dark so fast.
Wow, it's like night just descended on us.
And look at the crescent slowly disappearing. Crowds cheering here. Cell phones up, cameras up. 5, 4, 3, 2, 1, and totality. Totality, everyone.
Oh my God. Oh wow. Oh my God.
I was so nervous.
Wow. I know, I wasn't sure because we had some high clouds, but oh my goodness, you can see that corona extending out. Oh wow.
Yeah, the clouds were really bothering me and really scaring me. It get very cloudy here in the last hour and a half, but we have a great view here in Cleveland, Ohio.
Yes.
Wow, look at the corona.
You can hear the crowd. Wow, everybody's got their phones out.
Oh my gosh.
Wow. I saw pictures of what the shape of the corona might look like from our NASA scientists, and it looks exactly like they predicted.
Oh my gosh. Oh, and you can see Jupiter and Venus.
Oh yeah, look at that.
So Jupiter's to the upper left of the eclipse that we're watching, and just to the right of it is Venus.
Yes. Oh, and I see some of those pink protuberances we've been talking about all day.
Wow.
Beautiful.
And again, all around us you see light, but just at the top where we are.
360 sunsets.
Exactly, exactly. Yes, Indianapolis had described that as well.
Woo!
We have totality here for 3 minutes and 50 seconds.
That is such a luxurious amount of time. I saw the 2017, I think we only had about 2 minutes. So.
And why is that? Why does the length of totality differ?
Oh yeah, well, because sometimes the moon is a little closer, a little further away. Its orbit's elliptical. And so when it's further away, it looks smaller in the sky, but when it's closer, it looks bigger, and so we get a little bit more extra time.
Look at the prominence. You can see it on the bottom. On the bottom there.
So pretty.
Wow.
It's like bright pink.
That is insane that you can see it from there. From here.
Yes.
Just like the power of our sun. I'm truly in awe right now. And cold. I'm in awe and cold.
It did drop.
It is
dropped
noticeably
probably 10
colder.
degrees. It's like, yes.
Yes. Looking around to the crowd. A lot of people videotaping it, trying to take photos.
It's the lovely backdrop of the Cleveland skyline.
Yeah, that's beautiful. We have the stadium right next to us. Oh my gosh. And again, thanking the Great Lakes Science Center and NASA for hosting this event here in downtown Cleveland, Ohio.
And it's great to like sort of join humanity to all come together at once and experience this together with such a great
Oh,
group
look at
of
the screen
folks.
right now. Here's a shot of the skyline.
Oh,
wow, the
wow.
sky looks on fire. Beautiful. A lot of excitement still here in the crowd. Sarah's just taking it all in. Sarah, you're supposed to be commentating. You're supposed to be saying.
It's so beautiful.
So you can tell that we have some cloud cover, right? It's kind of hazy here, but still.
It is, yeah, some high clouds. I was worried about it, but like we can still really see, have a pretty good view here.
Wow. And again, this is so rare for people here in Cleveland to see a total solar eclipse. The last time was 1806.
Yes.
The next time, guys, 2444. That is incredible.
I hope everybody took the time to come outside and witness this today.
Oh my gosh, you can still see that prominence. Again, talk to us about what a
it's so
prominence
beautiful.
is.
Yeah, so that pink color comes from the helium in the sort of outer atmosphere of the sun there. Oh, it's beautiful.
And it gives off that pink glow.
Yeah.
Wow. Totality
here
ending
comes-
here.
here comes
Whoa,
that-
there's the diamond ring. Oh!
Time to get your glasses back out.
Time to put your glasses back on, everyone. That's your cue. Glasses back
cue.
on.
We get
Wow.
that diamond ring.
Wow. What an amazing experience. My first total solar eclipse.
Yes.
Let's see what they think about this in Niagara with Daryl Nail.
Over the entire area. You can hear the crowd erupting at various moments when the eclipse has been seen, but we are under pretty cloudy conditions, and David Sheeny is with us. He's a program executive with the Heliophysics Division. David, this is a challenging situation to be in order to try to see this eclipse. We've seen glimpses.
We have seen glimpses, so we're basically spending our time staring at the sky, hoping for a little bit of a glimpse of what would be a totality. So right now, the sky has just completely gone dark. You can see all the lights, basically, everybody's cameras and everything else are all making it lighter. And it's gotten significantly colder as well, just over the last several minutes.
And it's fascinating to see it go night like this. We've been listening to everybody across the country enjoying totality and seeing it clear. That's not the experience we're having here. In fact, it's so cloudy that our telescope operator, Jessica Bellina, who's working very hard to try to get a lock on it, has not been able to get that telescope feed dialed in because she has to have a view of the sun in order to see it. So we don't have a feed for you from Niagara. What we have is just every once in a while you'll hear part of the crowd, only part of the crowd.
There's a drone up there in the sky too.
Oh my goodness.
Oh, wow.
It's incredible, the rays that you can kind of just see coming off of the corona.
Yes, yeah. Stunningly beautiful.
Yeah, that's got
it-
to be one of the most amazing things I've ever
And
seen.
you can see the gradation in the sky color
Yes.
down to the horizon
Oh
too.
my goodness.
Yeah.
I am seeing a bit of that 360-degree sunset.
Yes, yeah.
That is really cool.
It's amazing. Even though we're in the total shadow
Right.
here, there's still the corona is still pretty bright.
It is incredibly bright.
You could read by the light of the corona.
I think I would have some trouble reading, but I probably could. I could technically read something. So, Eric. Oh, and actually, we have the International Space Station flying over right now. So they are actually seeing not one, but two views of the eclipse. They're able to see not just the moon passing in front of the sun, but they're also able to see the shadow of the moon passing over Earth, which is absolutely incredible. I mean, I can hardly imagine a view being better than the one we have right now, but if there is one, it's
probably on the space station.
It's from
yeah.
the space station for sure. Wow. So yes, they're able to take some pictures of that, and that is just incredible. Just incredible.
one of the things they told people to do if you're far away was to hear how nature changed. And it was interesting here. We're, of course, surrounded by a lot of people just to hear their reaction when we went into totality.
It's true. The humans in nature have not gotten quieter, but louder, I would say. But, I mean, you can definitely hear the loudness has a different kind of character to it. There's almost like a, I mean, I don't know if wonder has a sound, but I think this might be it. Yeah.
Hushed awe.
Yes, hushed awe. That's wonderful. And I can see just one little red, I guess, like protrusion coming down
little
there.
red spots almost. I noticed those too.
That's cool. Now there are two.
Yeah.
Wow. That is just so cool.
Yeah, I like the 360 sunset. It's a little hard to see behind us, but it's.
Oh, we've got at least one or two drones.
Yeah, some our robot overlords.
Of course. And so, Eric, I know that, I mean, clearly with the drones, people are starting to get involved in the eclipse, and I know that there are lots of ways that people can actually get involved. One of those ways is with citizen science.
Right.
Do you mind talking about some of those opportunities, how people can actually...
Sure. We had citizen science programs where people could use their cell phones to take pictures during the eclipse. And
we're getting ready to come out of totality. We're just putting our glasses on.
And here we go. Put those oh, there it is. Oh, it's peeking out.
Everybody is cheering. We have just made it to the end of totality. We're starting to see the sun just peeking back out
amazing.
Again.
Now just look at the ground, how much brighter it's gotten.
It is already so much brighter. That
three things, and they never will. And so NASA Glenn is literally part of virtually every NASA mission.
Well, Jimmy, thank you so much. I really appreciate you being here and again hosting us. This was a wonderful event. I know so many people joined us here and really enjoyed it because we were watching, we were looking out at the crowd, lots of smiles. So really, thank you so much, you and the Great Lakes Science Center.
And thank you for being here and being part of this with us and really putting NASA and NASA Glenn on the map here for us.
Thank you, Jimmy. Thanks so much. Have a great day. All right, and a big thank you to our whole team positioned across the path, from our correspondents to our experts and our telescope operators. We couldn't have done it without all of you. And Sarah, as we're taking again this aerial shot of the Great Lakes Science Center, so beautiful. Such a wonderful way to experience my first total solar eclipse, and I hope you had a good time too, because I know this isn't your first total solar eclipse.
No, this is my second, but it was really great and special to be able to experience it with you and all the folks here.
Yeah, we did notice that people right after, the people were like, whoa, they were trying to get out. There's a lot of really fun events happening in Cleveland, so there's a lot of people in downtown. So I hope that they took some time to look up today and really enjoy what they saw.
Yeah, and not only all of the great views that we had, but we also really did some cool science today too.
Yeah, really, really cool science. And actually, yeah, let's talk about that. You know, NASA's heliophysics big year isn't over yet. You know, we had the annular eclipse, then we had the solar eclipse, and now talk to us about what's happening in December.
Yeah, coming up on Christmas Eve, in fact, Parker Solar Probe will make its closest approach to the sun, 3.9 million miles, which still seems like a long way to me, but apparently that's actually pretty close.
Yeah, I can't believe that's happening. Again, just that it's all, we've been saying this all day, aligning. Everything is aligning for us to have a beautiful show. And so, yeah, you know, Sarah, again, thank you so much. You know, we watched this together, race across Mexico to Maine in only an hour and 28 minutes. And again, we have so much more to look forward to. So we hope you all stay with us as we continue studying our sun and how it affects us, from all of us here at NASA, where we make air and space available for everyone. Thank you for watching and enjoy the rest of your day.
We are one of 100 billion stars in a vast galaxy, but for all of human culture on Earth, one sun that nourishes us all.
That is what stirs humankind. That's what unites us.
Experience the wonder, the beauty, and the power of our star.
One sun across space, time, and culture.
Let us continue the quest to unfold this universe. And let us continue to find unity in our discovery.